All right, I'm gonna take y'all out with me today, and we're gonna drill a well. And this is basically kind of gonna be all about casing, because I know I got a lot of questions about casing. How do we set plastic? How do we adapt plastic to metal? So on and so forth. So what I'm gonna do, I'm gonna show you, this is our plastic to metal transition coupling. In case anybody else wants to learn how to do this, this is what they are. 6 by 9 by 6, 6.9 by 6. But basically this side you can slip PVC into, and then this side slips over metal. So let's go outside and I'm going to show you exactly what we do. So metal casing comes in two different styles. They have coarse thread and they have fine thread. So this right here is fine thread. And this stuff up here, this is coarse thread. And what we've learned is the coarse thread is actually a slightly smaller outside diameter, and the plastic transition coupling slips over it too loose. The fine thread, it fits nice and tight. So what Mike is doing, we take a 21-foot section, we cut it in 3 pieces, so that's 7 foot. Now there's another rule of why we want 7 foot, because the length of our 6-inch hammer and 6-inch bit is roughly 6 foot. So we want that entire hammer to be inside of a piece of metal down at the bottom so it doesn't break the plastic. And especially if we're in really rough or jagged rock formations, or we set really deep casing, we go ahead and put the metal on the bottom, and that prevents any cracking of the base of the seal of the casing to where we don't have any failure. In order to cut it, you got a big metal pipe cutter here, and once, I'm going to show you the end of it inside here. Once you cut it, you've got 2 ends with threads and then 1 end that doesn't have any threads. These were probably your threaded ends. And you got this little lip right here. That's where it stops. So we just clean it with PVC cleaner, put glue all over the metal, glue on the plastic, and we beat it on with a 4x6. Oh, another key thing that you have to do is when you cut them with the casing cutter, it creates a flared lip, one that goes out and one that goes in. So the one that goes in is going to make the ring right on the outside a smaller diameter. So you got to take a grinder, you got to grind all that lip off of it. You can see right here where he ground down. So we're grinding that lip so it doesn't hang the drill bit as it goes through or comes back up. Now, quick side note, I just want to reiterate this. You have to really inspect these. So I just finished cutting this one right here, right? So piece 1, piece 2, piece 3. The center section, you got to grind both sides. Now, as I was cutting this one, I looked and I saw this is where they picked it up with the forklift. And they dented it. I don't really know if you can tell, but they dented it. 6-inch pipe. We got to stick a 6-inch bit through here, a 6 and an 1/8-inch bit. Now I'm going to show you. Let's see if we can roll it. I'm not sure if I can catch it on. Yep, there it is. So see the dent? We cannot use this pipe because of that little dent right there. The carbide will snag it. It'll lift the casing up, and it will remove the nice seal, the nice seat. So the only thing I could do to try to save this piece is maybe weld something on it. I could possibly weld like a nut right there. That would heat it up, and put a slide hammer on it and pull it out. That's the only thing I can do to try to save that. But for now, we're not going to put anything on this. Just going to set it off to the side. I'm going to let Dad look at it, see what he wants to do. But just based off the size of the dent on the inside, I know the bit's not going to make it past it. So got to make sure that there's no dents. And really, when you look down inside of them, you can really tell quite easily if you see any non-smooth sections. All right, we've got glue and primer on the metal, glue and primer on the plastic. Slip it on. Mike's gonna give it a couple easy taps, then he's gonna whack it. It's good. When we look down in here, see? Boom. Good to go. Once the glue sets up, she's rigid, man. She's solid. Works great. Well, thank y'all for joining me. Today we are going to be drilling a well out here, and I'm going to cover the topic of casing. This white pipe here. We install 6 1/4 inch PVC casing. Some wells require metal casing, so on and so forth. It depends on the classification. There's a whole lot of variables, but we always start off each well cutting with a wing bit. This will be a 10 to 11 inch bit. It's basically going to cut 20 feet as our pilot hole. It's just the two of us drilling out here today, so hopefully we don't have too deep of a casing set. We have our initial first 20-foot pilot hole dug, and now it's time to install the larger 8-inch hammer with a 10-inch bit. The difference between the wing bit and the hammer, the wing bit is basically just to cut through dirt. It does not cut rock very well. The 8-inch hammer and the 10-inch bit, you can tell by the percussion of the hammer, is designed to cut through dirt, sedimentary rock, and granite. So after the first initial 20 foot, we install the large hammer, and then we go in search for granite bedrock. Once we hit bedrock, we drill about 10 to 15 feet. Then we install our casing. So now we're in search for bedrock. What I'm showing you here is what we do to reinforce the base of our plastic PVC casing before we install it in the ground. If we go past anything past about 80 foot, we transition over to metal casing. I am showing you this just for the sake of the video. When I tap on the plastic drive shoe here, I make sure that the cut end goes on first. That way that the true end is facing downward. Now I do not glue this on, no primer, no nothing, just forceful fit. That way in the future, if you needed to pull the plastic casing out, you could do so. Sometimes if you install it and you glue it on there, the casing doesn't want to pull out of the hole. This added protection helps to prevent the inside pipe from cracking, and it also helps to make a larger diameter outside seal, and that way when all of the chips and everything from the rock cuttings, it will actually give a larger area to help seal the base of the casing. Well, as luck would have it, we're not going to have a shallow casing set, so it looks like I'm going to have to ditch the plastic drive shoe idea, and we're going to have to install a 7-foot piece of galvanized metal at the bottom of the casing. "110 foot to bedrock, 118 foot of casing being installed." Surprisingly enough, we were able to actually get the casing about 1 foot from being completely on the bottom. So we got really lucky to set this deep of casing in for it to go that far down.
On the bottom, baby!
Looks like bedrock consists of a mixture of granite and quartz. What you're about to see is exactly why we install a 7-foot piece of metal on the bottom of the casing. If you notice, the casing is going to start rotating. It's rotating because rock, gravel, chips are trapped between the bit and the casing. The hammer itself is about 3 foot off the bottom based on the mark on the drill rod. That means we have percussion of the hammer firing inside of the casing. Right now you see it's blowing out all of the air around the outside of the casing. This is good. This is going to push all of the rock chips, dirt, and water away from the base of the casing. It's going to blow out. You go down, you start drilling. Now you've got all the trash clear from the base of the casing. And once it quits, just like that, it's good to go, good to start drilling. You know you've got a good seat. We know based on the gray color that we are in gray granite, which is excellent. But a key thing to setting casing is what we're about to do right here. If you notice, we are pulling the drill bit back out. What we're doing, we're rotating the drill stem, rotating the bit, pulling it back up inside the casing. Sometimes the casing is off to one side, which will cause a lip. At the end of the day, if you do not do this, your bit will hang the casing and lift the casing out of the hole. So what we do is we bring the drill bit back up, rotating it through the casing. This centers the casing in the hole. It's key to do this to make sure that the casing itself is exactly in the center of the borehole. The second thing that we are doing is we are going to push on the casing. Not hard, just the weight of the drill stem. This makes sure that the casing is pushed all the way on the bottom. You must be careful because you can break that transition coupling. I've done it before. You've watched it in my previous video when I put too much pressure on it and I broke the transition coupling. I'm still new, I'm still learning. Put too much pressure on it. That was my fault. But it's the first time I've ever done that. It's just things about well drilling you learn along the way. Hopefully you're enjoying this. Hopefully you're learning something. This was a really big job, a really long day for just me and Dad, but we handled it no problem.
So as you can tell, we got casing set, about 118 foot I believe, and everything went smooth. Now typically when you set deep casing like that, if you run into a situation where the casing won't seal and it won't seat perfectly, you have to dump a bucket of gravel down in the well after you drill a little bit. So we set, 118 plus foot of casing, and then we drilled to 127. You have to drill that little bit and then come back up to make sure the casing seats. If not, you dump some gravel down there, and the gravel helps go around the base of the casing and catch any sediment, any grit and stuff like that to bind it up to create a nice seat. I'll show you what we use.
We simply just carry 2 buckets of gravel with us on the truck. Sometimes it only takes maybe a half a bucket poured around the outside of the casing to help it to seal. We had to do that yesterday, and I didn't know if we'd have to do that today or not.
Today's lunch is brought to you by my girlfriend. I can tell you, man, I've got a good one.
Just hit water. A little dirty if you just hit it, but it should clear right up.
$265 foot deep, 8 to 10 gallons per minute. What a beautiful well. Time to trip out, overream the well, and grout it. Alright, well, we're all completed. We still got to dig up our wood, and we'll be back here tomorrow to put the pump system in. But 265 foot, 10 gallons a minute, and 118 foot of casing, and a whole lot of mud. Not bad, not bad. I'm tired. Running out of battery, and I'm running out of daylight.
Boy, oh boy, I'm spent. I ain't got nothing left. It's tough when you're a man down. Mike is currently in North Carolina helping out with the relief efforts from the storm. And, you know, he went with us today. It's just a lot. It's a lot for 2 people to do. But we got it all done, and we'll be back here tomorrow. And I'm ready to go home, put some fuel in this thing, get to my house and take a shower and go to sleep. Because I'm dead tired. Thank y'all for watching. I'm sure by now, whoever's giving the video a thumbs up is already done up. There's no need for me to even ask y'all to do that, because I appreciate y'all. I will see y'all on the next one. Woo, what a bumpy road.